In this tutorial, you will build a note-taking app with an AI chatbot using the Vercel AI SDK, Convex, and the OpenAI API. Let's take a look at the app we will build. We have a login screen. We can create a new account or log into an existing account. And this is a basic note-taking app. We can create notes, we can delete notes, but the really cool feature is this AI chatbot, which can find any information in our notes and answer questions based on this information. For example, I have this note that contains my password. Let's say I want to find this Wi-Fi password, but I don't want to search myself. I can just ask the AI, what's my Wi-Fi PW? Send this. Now the AI searches through my notes, it finds this information and then it streams in the response. We have rich formatting. We even get a link to this note where the information is found. Really cool. Let's ask a follow-up question. Give me my grocery list, please. Again, it searches through the notes. It finds the grocery list and it returns them in this nice formatted list, again with a link to the relevant note. When I write something that doesn't require a search through the notes, like thank you, then it will not search this time, it will just answer right away. So the AI decides if it should search through the notes or not. And the cool thing is this will work no matter if we have 5 notes or 5 million. It will always pinpoint the exact information that we need and ignore all the other nodes. For the backend of our app, we will use Convex, who are also sponsoring this video. And they are really cool because you have everything under one roof. Database, authentication, even the vector storage. So we don't have to use a separate service for that. And they are free to use. So what more do you want? Welcome to Coding in Flow. I'm Florian Walter and I make web dev tutorials that cut the fluff and get straight to the point. If you want to learn at high speed, subscribe to the channel. For this tutorial, I've already prepared the starting code so that we don't have to write everything from scratch and can focus on the interesting parts instead. I will put a link to this GitHub repository into the video description. The default branch is called starting code and we want to clone this repository. So we copy the URL, then go to the folder where you want to put your project, open the command line here. On Windows we can do this by holding Shift down, right click, open PowerShell. And here we clone this repository with git clone and then we paste the URL and we execute this. Of course, this requires you to have git installed, but I assume that you already did this. If not, please Google for git installation, install it, and then you can run this command. This clones the repository that we just saw on GitHub into this folder. And we want to open it in VS Code. Okay, so there's already a bunch of code in here, mostly UI elements, because this is boring. It's a Next.js project and we use Chatc and UI components, but this is not so important. More important is that we open the command line and run npm install to install all the packages that are listed in the package.json. All the stuff here that we need to get this baby running. We wait until this is finished. Looks like everything went well. And now we can run this with npm run dev. And then we can open this website on localhost 3000 on your computer. Let's see at the starting code I prepared. This is the front page, nothing special. We don't have a login screen yet because we will implement authentication together. And we can open the form, but we can't yet actually create a note. When we click save, nothing happens. And the AI chatbot also doesn't yet work. We can't even send messages. We will implement all of this together, but hey, at least we already have dark mode. Yay. Next, we want to set up Convex together. So Convex is basically our backend. It includes the database where we store our nodes. It will also provide authentication, so we don't need a different service for that. And they have a ton of different features, even file storage, and they are free to use. So this is really cool because then we don't have to sign up for a lot of different services. We have everything under one roof. And this quick start guide explains how to set up Convex with Next.js, but I will walk you through it. So we go back into VS Code and open our project here. We open the command line. We stop the execution for now with Ctrl-Z. And then we run npx convex dev instead. Careful, this is not npm, this is npx. When we run this command, it executes the convex package that I already installed in the starting code right here. And it asks us a bunch of questions. Would you like to log into your account? We select login or create account. We can confirm the default device name. And here we confirm with Y, which now opens Convex in our web browser. We confirm this, and then we either have to create a new account, or if you already have one, log into it. I'm gonna go ahead and create a new account for this example. There we go. We can close this for now. Back into VS Code. Do we agree with the terms of service? Yes. We keep the default project name, which is the name of the VS Code project. And now it creates some stuff, including some files in this project. There we go. Let's take a look at the files it created. So it created this Convex folder in our project here and some generated files. When we later make changes to our code, these files will automatically be generated again with the latest updates. And for this, we have to keep npx convex dev running all the time while we are working on our project. Or if we stop it, we have to run it again later, because this moves all the changes from our code into our Convex project, which we can find under this URL. We will take a look at this in a moment. But again, you always have to keep npx convex dev running. If you stop it, then run it again via the command line. And then we have to open a second terminal for npm run dev to run our Next.js project. So these two will be running at the same time, npx convex dev and npm run dev. Okay, besides this convex folder, it also created this .env.local file with two environment variables. The name of our convex deployment, this will be different for you, and this convex URL that we can use on our front end. Let's add one more environment variable here called next public base URL, and we set this to localhost 3000, which is the base URL in development. In production later we set it to a real production URL. And then in order to use Convex on our front end, we have to set up a context provider. Again, this is described in the Convex documentation, but I will walk you through it. So we go into this app folder here. We right-click directly on app, create a new file called convex-client-provider.tsx, like this. We make this a client component. If you don't know what a client component is, those are Next.js basics. You can watch my Next.js beginner tutorial or just follow along. It's not so important for this project. In here we create a const called convex, and we assign it to a new convex React client, which adds this import statement. Parentheses. Here we need our environment variable via process.env. And then we need the next public convex URL, this one. And we have to add an exclamation mark behind it to assert that this value is not null. And then we export a function called convex client provider, like this. It will take the children as prop of type React node. This is just a regular React context provider, which are React basics. And here we return a convex provider, which adds another import. We pass the client as a prop to it, the convex client. We close this, and in here we want to render the children, which are all the pages that we wrap into this context provider. And this simply makes this convex client available throughout our whole app, because we wrap our whole app as the children within this provider. Again, context providers are React basics. If you don't know how they work, you can just follow along. But I have a short 1-minute video on YouTube where I quickly explain how to set up a context provider and what it is. You can just search for coding and flow context provider. But we also have to use this provider somewhere, otherwise it won't come into effect. For this we go into this layout.tsx file in our app folder. And this shouldn't be complaining, I think this is just a bug. I'm gonna try reloading the window, which reloads VS Code, and just hope it goes away. Looks like it worked. And then we wanna wrap these children here, which are all the pages throughout our app, into this convex client provider that we just created from this convex client provider file. We close this and remove the closing tag below the children. And now all the pages in our app have the Convex client available. And this is enough to use Convex features in your React app. And next we will set up authentication. Authentication is also provided by Convex. We could use a different authentication provider, but it's nice to have everything under one roof, because then our user data will be stored in the same database as our nodes, which is really useful. There are docs on how to set this up, but again, I will walk you through it. So we open the command line again. Actually, we need a third terminal. So let's open another one. And then we run npx add convex -dev/auth. Make sure to spell this correctly. We run this, which again goes through a bunch of different steps to set up authentication. Enter the URL of your local web server. That's localhost 3000, which is the default. Then it configures some keys automatically. And it does some other steps. And in the process, it set up a bunch of new files again. Let's take a look. First, we have this auth config.ts file, which configures Convex authentication. Now this complains, but this is actually fine. We don't have to change anything in here. In case you are wondering where this environment variable is coming from, this is not coming from our own .env.local file. As you can see here, this Convex site URL is not in here. This one is stored in our Convex dashboard, which we will take a look at later. Because we don't use Next.js as our backend, we use Convex as our backend. So this is also where we have to put these backend environment variables. In our Next.js project, we only have these front-end environment variables. We also have this new HTTP TS file, where it added these auth HTTP routes, which are required for authentication. We will come back to this file later, and then we go into auth.ts, which is also a new file that was automatically created in the Convex folder. So it's in here, in this Convex folder. And in here, to enable password authentication, we go inside this providers array, type password, but we have to import this. The import statement looks like this. Type this out by hand if necessary. And this is how we enable password authentication. There are also other options like social login, Google login, GitHub. But for this tutorial, we will only use good old email and password. Next, we have to set up our database schema. For this, we right-click on the Convex folder, create a new file with this exact name, schema.ts, right in the Convex folder. Here we create a const schema, and we assign it to define schema, which is an import from convex/server, parentheses, curly braces. In here we spread with ... the auth tables, which is another import, this one here. This contains the database tables for authentication, so users and sessions and all of this stuff, and we just put them into our database schema. And later here, we put our other tables. For now, we keep it like this, but we have to export default the schema to activate it, so to speak. Next, we go into the Convex client provider that we created earlier. We actually have to replace this Convex provider for a Convex Auth Next.js provider, but it looks like the auto import doesn't work, so I import this manually. Go ahead and add this line. And we want to use this here instead of the default Convex provider. This is necessary for Convex authentication to work with Next.js. Next, we go into the layout.tsx file again, the one in the app folder. Now we have to wrap everything inside return, including the HTML, into a Convex Auth Next.js, but not this one here, not this Next.js provider. This is a different import, which again I add manually. It's called Convex Auth Next.js server provider. We need this in order for Convex Auth to work server side and not just client side. So we put the opening tag here and the closing tag here at the end of the return statement, like this. And in here we still have the Convex client provider. This is the setup we need. Okay, next we need a middleware, which we have to put directly into the src folder. So right click on src, middleware.ts. Middlewares are a Next.js feature. And in here we want to block certain features behind authentication so that we can only open them if we are logged in. And I'm just going to copy paste this code because it's tedious to set this up by hand, and most of this is just copied from the Convex documentation. I will put a link to this middleware file into the video description below. You can copy the code from there into this middleware TS file. And what this does is, every time we open a page in our project, it will check if this is a protected page or not. And if it's protected and we are not signed in, it will redirect us to the sign-in page automatically. Everything behind /nodes is a protected route, as you can see here, and will require login. The front page, which is not under /nodes, is not protected, so we can open it without being logged in, which makes sense, right? And if we try to open the sign-in page while we are already logged in, we automatically get redirected to /nodes. And this is basically all we are doing in here using Convex features. Again, you can copy this file from the video description. And let's try this out. Let's open localhost again under /nodes and let's refresh this page. We should get redirected to the sign-in page. No idea what this is. Maybe let's restart our app. Let's restart both Convex and our app. So we open a terminal, npx convex dev. Remember, this always has to be running to synchronize the changes between your code and the Convex backend. That's what it's doing here. Open another terminal, npm run dev, and then try this again. Refresh the /nodes page, and voila, we get redirected to the sign-in page automatically. Let's try this again. /nodes, we get to the sign-in page because we protected it in our middleware, but we can open the front page because this one is not protected. Nice. This sign-in form was already part of the starting code. We can find it in the sign-in form tsx file in here. But again, I don't actually handle authentication yet. Instead, I left this to-do comment in the onSubmit function. So let's finish setting this up. Up here we have this step state, which is set to either sign in or sign up, because in Convex we actually have a single sign-in function that handles both registrations for new accounts and signing into existing accounts. And via the step we can differentiate between these two different situations. For this form and also the form to create a new node later, I use chatcn form components together with React hook form. I've already set this up. This gives us cool real-time validation. So if I don't type anything in here, it says please enter a valid email address until this actually looks like an email, and I have to insert at least 8 characters into the password field, and the same for signing up. These error messages and the validation are handled in this schema.ts file in the auth folder. This is the SOT schema, which checks that the email is a valid email address and the password has at least 8 characters. This 8-character rule is also enforced by Convex by default. So Convex requires to have at least 8 characters in the password, and I copied these requirements into our front end. You can change these password requirements. You can read about this in the Convex documentation, but I want to keep the default of 8 characters. Okay, back to the sign-in form. Here below the step, we create a const and destructure it, and we call the useAuth actions hook. Looks like auto import again failed me. It's this one here from Convex dev auth React. We want to call this hook here because in here is the sign-in function and sign out. Then we want to create another state called isLoading and set isLoading. So we have a loading state while we are logging in. We have to handle this ourselves via a useState that we initialize with false. And lastly, to later redirect the user after they logged in successfully, we need a router, which we can get from the useRouter hook. Important, we need the one from next/navigation, not next/router, because this one will not work. Next/navigation. Parentheses. Okay, perfect. And when we submit the form, the onSubmit function will be called. And in here, we want to handle the actual login or sign up, depending on which step is active. So we start by creating a try-catch block, because this operation can fail, in which case we want to show an error message. But above the try, we set isLoading to true first to show the loading state. Inside the try block, we call await, We call the sign in function that we got from this useAuth actions hook right here. We call this parentheses. The first argument is the provider. We want to use the password provider for password login, comma, curly braces. And in here we have to put the email and the password that we want to send to the backend, which are these values here. This is whatever we typed into the form. So we spread these values like this. And then we also have to set this flow value to the current step. This decides if we are trying to register a new account or sign into an existing account. After this succeeded, so below await sign in, we want to show a toast message. For this we import toast from Sonner like this. I've already set up the toaster in the root layout right here. This is responsible for showing these toast messages. And now we can just call toast.success to show a success message. And in here we put the text of the toast, but it depends if the step is sign in or sign up. If it is sign in, we want to say signed in successfully. And if we created a new account, we want to say account created successfully. Makes sense, right? And after showing the toast message, we want to redirect with router.push to /nodes. Pretty simple. So we sign in by sending the values to our Convex backend. We show a success message and then we redirect to /nodes. In the catch block, we want to show an error message and log the error to the console. So we start with console.error. We pass the error here. And now we want to differentiate between expected errors and unexpected errors. An expected error is, for example, if we type in the wrong password, because this can happen and it happens often. And then we want to show an error message in the UI that says invalid credentials. But there are also unexpected errors. For example, when the backend is down for some reason. Then we want to show a generic error message that just says something went wrong, please try again. And this is what we do inside this catch block. The only problem is Convex Auth right now doesn't have a nice way to distinguish between these different expected errors. They are working on this, there is an open GitHub issue, but for now we have to work around this a little bit. So we do the following. In the catch block, we check if error is an instance of the error type, because we can throw everything as an error. Still inside the parentheses, we write 2 ampersand signs, and in here we put another pair of parentheses, just follow along. And we check if error.message.includes this exact string, invalid account ID. With this spelling, make sure to spell it in Pascal case with uppercase first letters here. This means the email address is wrong. And then we also want to check if the password is wrong. So 2 vertical bars, error.message.includes invalid secret, again in Pascal case. So we check if error is an instance of error and the error message includes either invalid account ID or invalid secret. In both these cases, we want to show an error message in the UI that says invalid credentials. It's good practice to not tell the user if it's the wrong email or the wrong password, because then it's easier to hack the login via brute force. It's better to be a bit vague and just say invalid credentials. Maybe the account doesn't exist. Maybe the password is wrong. Maybe the email is wrong. You don't want to be too specific. So we handle both of these cases together. Then we take this form, which is this object here. I already set this up in the starting code. This is coming from React hook form, and this manages all the form state. So we take this form and we want to set an error on here. Parentheses. Here we set this to root because this is a root error. Comma, curly braces. We set the type to manual, like this. And the message to invalid credentials. Now this looks complicated, but all this does is setting an error message on our form, and somewhere down here we render this error message here. Form state errors.root. If it is defined, we render it here. And this up here is how we set this error. Okay, But as I told you, we have expected errors and we have unexpected errors. Those are the expected errors, if the email or the password is wrong. After the if block, we add an else. If this is an unexpected error, we want to show a toast.error message instead that says something went wrong. Please try again. And this could be anything. This could be that our server is down or something is wrong with our setup. Then we want to show a generic error message because we don't know what exactly is wrong. Okay, I hope this makes sense. So now we have try, we have catch, and after the catch block, we add a finally block where we want to reset the loading state back to false, so that we stop showing the loading indicator, no matter if we get an error or if this succeeded. Okay, this is actually it. One more thing I want to do. Down here we have the submit button, and I want to disable this button if isLoading is true, so that we don't click login twice in a row. Okay, perfect. Let's save this and try this out. But keep in mind that Convex Dev has to be running all the time in the background to synchronize these changes to the backend. Okay, let's open our app again on localhost 3000. Let's refresh the page just to make sure. And then we have to click on sign up to create a new account. First, let's try our error message. So if I try to sign in with an account that doesn't exist, it will say invalid credentials. Perfect. This is exactly what we want. Now let's create a new account. We also have this password toggle, by the way, and this is my super secret password, which I use for all my private accounts as well. Let's try to create an account. And voila, account created successfully. We are inside our app. Now let's also implement this logout button here, which doesn't work yet. In our main layout here, not the root layout, but this other one that only wraps these main pages, we have the navbar already set up. In the navbar is the sign out button, and you can also open it directly. Just search for sign out button TSX, and here the on-click handler right now is empty. You already saw earlier that we can find the sign out function in the use of actions hook next to sign in, this one here, and we want to call it here via sign out, like this. Let's save this and try it out as well. Now when we click this button, we should be signed out. We get back to the login screen. Let's try logging in with this account. First, I'm gonna set a wrong password, sign in, invalid credentials, correct credentials, and boom, we are logged in. Super cool. We can also take a look into our Convex dashboard. We can actually open this via the command line. Let's open another one. And I think the command was npx convex dashboard, which should open it in your default web browser. For some reason this doesn't work for me. We can also go to dashboard.convex.dev and log into our account. And this is our Convex dashboard, and here's our project. This is our whole backend. Let's take a look into it. Here we can take a look at everything. The logs, our database, settings, functions, and in this data tab we find our different database tables, and those are the auth tables that we set up earlier in the auth config, no, actually in the schema file, this one here. Those are the auth tables. Those are the ones that we can now find here. And in the users table is coding and flow recording, and here we can set a bunch of metadata if we want, but for now we keep it simple. And next we want to set up a nodes table so that we can create nodes and also store them in this database. And later we use AI to search through these nodes. Let's go back into our project and open the schema.ts file in our Convex folder, this one where we already have the auth tables. Now here below we want to put a new table for our nodes, which we do like this: nodes column, define table. Of course, this is described in the Convex documentation, parentheses, curly braces, and in here we define the schema of this table, the different columns that we want to have in here. So each node should have a title, then we write colon, and then v, which is an import from convex/values, dot string. This way we set the type for this column in our table. So the title is a string, We also have the node body, which again is a string. And each node should be tied to a user, right? So we also store the user ID in here with v.id. And in here we write users as a string like this. Why users? Because this is the name of the users table in Convex as we saw earlier. The users are stored in this users table and the user ID should connect this node to a particular user in this table. Okay, and after the find table right here, after this closing parentheses, we create an index, parentheses, and an index allows us to search by a particular field later. We want to be able to search users by their user ID. So we have to give this index a name as a string, which we call by underscore user ID, like this, comma, and then square brackets, and in here the name of the field that we want to search for, the user ID, like this. Those are the schema changes we need. Let's save this. Remember, npx convex dev has to be running in the background in order to synchronize these new schema changes. As you can see, I added this new table and index. And then we create a new file in the convex folder, right click on convex, and we call it nodes.ts. And in here we put functions to fetch nodes, create new nodes, and later delete nodes from convex. And in convex it works like this. We export a const called createNode and we assign it to a mutation, but auto import doesn't work. We have to import it from this generated folder here, that's this one. In here is the server file, and in here we should find this mutation function that we want to call, parentheses, curly braces. In here we have to pass a bunch of different arguments. The first one are the args. Those are the arguments that this createNode function later expects in order to create a node. And to create a node, we need the node's title, which again is a v.string, comma, and the body, v.string. We don't need a user ID because we read the user ID directly inside this function. But these v functions here also validate the input. So if we later try to call this function with wrong input, for example, the title is a number, or we try to pass a field that is not part of the args, then this will automatically throw an error. So this is also validation at the same time, which is really cool. The second argument are the values that this function returns. Again, we use a validation function. This returns the ID of the node. That's the ID of the node we just created in this nodes table, comma. And the logic happens inside this handler. But I want to make this an async function. So I add a colon here, async, and I turn this into an error function like this. And I also want to remove this underscore 0. I don't know why it was added there. So in here we put a logic that will be executed when this createNode function is called. First of all, we want to authenticate the user, which we do like this. We create a const user ID, await get auth user ID, which is another import from Convex. And to it, we have to pass the context, which is this argument here that we get from the handler function. This way we get the user ID of the logged in user. And if the user is not logged in, it will be null. If this user ID is null, we want to throw an error, because then we shouldn't be able to call this function in the first place. Only logged in users should be able to create nodes, right? So we throw an error that says user must be authenticated to create a node. You can type in here whatever you want. Below, if the user is authenticated, we want to go ahead and create a node. We turn await context again, .db. This way we can access our Convex database. And here we can call insert. We want to insert something into the nodes table. And here we get autocomplete, which is really cool. Comma, curly braces. And in here we put the values that we want to put into this table. We get the title and the body from this args object, which are the arguments that we pass to this function. Pretty straightforward. So the same for the body, args.body. And the user ID is the one we get here from this authentication function. And that's already it. This function will later run on the Convex backend on our server, and we can call it to create a new node and put it into our database. Now we have to take care of the front end. Let's go into the create node button tsx file, which was already part of the starting code. And here we want to create our node when we submit the form. So here again on submit is empty. First of all, we go at the start of the create node dialog function, this one here. We create a const create node and we assign it to a use mutation, which again is coming from Convex. And in here we pass API, which is imported from this generated folder, .nodes, .create node. And autocomplete should show this function. But for this, again, it's necessary that we have Convex dev running in the background, because this is what creates this code. And now we have access to this create node function that we put here as a mutation into the Convex folder. Pretty cool, huh? And now in the onSubmit handler, we can use this function to create a new node. So again, we put a try catch block in here. In the try block, we call await create node, parentheses, curly braces. Here we have to pass the title, which is values.title, and the body, which is values.body. And values is the form input, the same as in the sign up form. Again, we want to show a toast message, toast.success, node created successfully. I also want to call form.reset to reset all the input fields. And then I want to call on open change and set this to false, because this is a dialog and this way we close this dialog. Okay. And the catch block, we want to show an error message. Error, creating node colon. And we can also put the error message in here to see what exactly went wrong. And I also want to show an error toast. Toast.error, failed to create node, please try again. Cool. Just one more thing, I want to disable the submit button while the node is being created, so that we can't click it twice in a row, right? And we get this information from this form state here. So here below const form, we create a const is submitting, and we assign it to form.formState.isSubmitting, this one here. I want to store it in this variable so that we can use it in multiple places without repeating this here over and over again. So back to our submit button, this one here. We want to disable this button while isSubmitting is true. And I also want to show a different message when isSubmitting is true. So here we put an expression, isSubmitting question mark, then it will say saving ... to indicate that this is currently saving a new node. Otherwise it will say save as before. Good, let's save this and try this out. Back into our app. Now we should be able to create a node. Create node button, we have form validation in here as well. Node 1, this is node 1. Yay. Let's try this out. We should see a loading state, saving, and it's really fast. The node was created successfully, but we don't see it on the screen yet because we haven't implemented this yet. We will do this next. But first let's take a look into our Convex dashboard again, because now we have a new table here called nodes, and in here is our node 1 connected to this particular user. Nice. In order to fetch nodes from our Convex database, we have to add a new function to our nodes.js file in the Convex folder. So we have this create node mutation, and above, you can also put it below, the order doesn't matter. We put another function, export const get user nodes. This one is not a mutation, it's a query, which again is imported from this generated file here. Parentheses, curly braces, this looks very similar to a mutation. Here we can also define the args, but this one doesn't take any arguments, so we keep this empty. We could also validate the return value like we did here, but then we have to add each of the fields that's contained in our node, which is a bit tedious, so we will omit this here, we don't need it. And then again we pass a handler. This time we only need a context. We make this an async error function, And in here we want to fetch all nodes for this particular user. So again, we want to authenticate the user via this function here, get auth user ID. If exclamation mark user ID, if it's null, we want to return an empty array. We could also throw an error, it doesn't really matter. Then below, if the user is authenticated, we return await context.db .query. We want to query the nodes table. You should get autocomplete here. Then we have to add the index. This way we can search and filter nodes by a user ID. For this we created this by user ID index earlier, if you remember in the schema.ts file, by user ID. Now we can fetch nodes by a user ID. And in the second argument here, we can pass a function. I don't remember, wait, this is called q, but I think I got this from the documentation. But here we write q.eq, which is short for equals. And here we can check that the user ID, comma, is equal to the user ID that we get back from the authentication function. This way we only return nodes for this particular user. After with index, we order these nodes by descending order. This orders them by the timestamp automatically, so we have the newest node at the top. If you want the oldest node at the top, then change this to ascending. And finally, we have to call .collect to return these values from the database. And this is how you fetch data from a Convex database. But of course, this is only the back end. We actually need to call this function on the front end. And we do this in the nodes page component, which is also part of the starting code. So here right now, the nodes are an empty array. We want to remove this part and assign this to useQuery, which is another Convex React import. And again, here we can call API.nodes, but we have to import API from the generated folder. .nodes.getUserNodes, which is our new function. And then down here we can render these nodes, right? So here we put nodes.map. We take each node and we want to render a node item, which I also already prepared. We have to give it a key, which is the ID of the node, and then the node itself, which we have to add as an argument. So this doesn't work yet. Let's go into the node item tsx file right here. Let's finish this first. We add an interface above the component function called node item props, like this, with a capital P. This will take the node, and this will be of type doc, which again is coming from Convex. This one here, the generated one. Angle brackets, and in here we set this to nodes. This is now a single item from our nodes table. When we hover over it, we can see all the values in here. The title and body, the user ID, which we added to the schema, and these two values were added automatically, the ID and the creation time. We want to pass these values to the node item. So here we put the node item props. Now in the node page, we can pass our node here to the node item, save this, back to the node item component, and now we want to render these values here. So instead of this hard-coded node title, we want to render node.title, of course, and the same down here for the body. Node.body, there we go. Now when we save this and go back to our app, we should see our nodes. Yeah, but I forgot one thing, the useClient directive. Let's go back. We have to put it into the nodes page at the very top, right here. The useClient directive, so that we can call this useQuery hook in here. Again, save this and go back to our app, and now it should work. There we go. There is node 1. We can't open it yet because we haven't set this up, but let's try creating another node. Node 2. Hello world. Let's save this and we get instant updates and see our new node. This is one of Convex's features. These queries automatically synchronize with mutations. So if you add new data, the front end is updated automatically. Really cool. We will implement our chatbot very soon, but first I also want to add a mutation to delete existing nodes, and then we are ready to take care of the AI. Okay, so when we click on a node, I want to open it in a dialog, and in there will be the delete button. So let's go back to our project and open the node item tsx file again. So when I click on a node, I want to open the node dialog, but there is a little quirk. I want to open it by putting the ID of the node into the URL as a search param. Why do I want to do this? Because this way we can easily let our AI later also open nodes, because then we only need a link to this URL with the search param. Whereas if we handled it via useState, it would be more tricky to implement this. And putting state into the URL is generally a good practice, because then you can refresh the page and you still see the dialog and it doesn't disappear. This will be pretty simple. So at the start of our node item component, we create a function called handle open node. In here we call window.history.pushState. The first argument is null. The second argument is an empty string. The third argument is the URL where we want to redirect to. We want to put the node ID into the search params. So we put a question mark in here. Node ID equals, and in here I want to put node.id. And I want to call this function when we click anywhere on this card. So we add an onClick handler directly on the card component and call handle open node. Let's save this and try this out. So now when I click on a node, you can see it puts the node ID into the URL. And then we want to show the dialog depending on this node ID. And you might wonder, why did I use window history push state instead of router.push that we normally use in Next.js? This is because this function here is faster. Router.push does a request to our server and it has to wait for the response. But this is unnecessary because we don't actually want to reload the page for new data. We only want to put this value into the URL. So history push state is instant, whereas router.push is slower. This is a little optimization. And here below this card inside this fragment, I want to render the node preview dialog, which I've already prepared, which will take the node as a prop like this. We don't get autocomplete yet because we haven't added the props yet. So let's go into this file, into node preview dialog.tsx. Again, we add an interface here, node preview dialog props, and it takes the same doc type from the generated convex folder that we used earlier, which contains our nodes table. So this again is a single node, which we want to pass to this dialog. Again, we want to render the node title here, node.title, and here we want to render node.body. But we also need a way to show this dialog, right? This is where we put this node ID into the URL. And the dialog itself will listen for this ID and then decide if it should show itself or not. For this we can use the search params in here. Const search params equals use search params from next/navigation. And then we create a boolean is open. And this will be true if the search params contains this particular node ID. So we check search params.get node ID with the same spelling as we used over here. These two have to match. And if this value is equal to the ID of this particular node, then we know that we should show this dialog. Makes sense, right? Then let's also add a function to close this dialog. Handle close. How do we close it? We just remove the node ID from the URL. Again with window.history.pushState. Again null, empty string. And then the current URL, window.location.pathname. And this excludes the search params. So we push to the same URL, but without the node ID search param. And then lastly, here in this dialog component, we set open to our isOpen boolean, and we set on open change to our handle close function. And now we should be able to show this dialog. Let's try this out. Let's save everything, go back to our app, and there it already is, because the node ID is in the URL. And the cool thing is we can even refresh the page and we still see this dialog because the state is stored in the URL. And we can open another node and close it by clicking on the X or outside. And next we want to implement the delete functionality. To delete a node, we of course need another mutation in our convex nodes file. So we have get user nodes, we have create node, and we export another const called delete node, which again is a mutation because we want to update our data. To it we will pass the ID of the node that we want to delete. Let's call it node ID, which is of type v.id from our nodes table. Again, we can omit the return type and pass a handler, which is an async arrow function that receives the context and the args as usual. And in here we put our delete logic. Again, first we want to check that the user is authenticated. We can copy this from the create node function. This part, paste it here. Then we also need to check that the node we are trying to delete actually belongs to this user, right? So we fetch this node with await context db.get. Here we have to pass the node ID via args.nodeID. That's the argument we pass to this function. If the node is null, so if it wasn't found, we want to throw an error that says node not found, because we shouldn't be able to delete a node that doesn't exist, right? Then, as I mentioned before, we check that the user ID of this node actually belongs to the authenticated user. If not, we want to throw another error that says user is not authorized to delete this node. This is important for security. But if all of this matches, we can finally call await context db.delete, where again we simply pass the ID of the node that we want to delete. That's our delete mutation. And this of course here needs to say user must be authenticated to delete a node, not create. Next we want to call this function in our node preview dialog, because this is where we have our delete button. So first let's get a handle to the mutation. Const delete node, use mutation, API dot, we have to import API, I always forget this, dot nodes dot delete node. And again we need a loading state so that we can't click this delete button twice. Let's call it delete pending or delete loading, doesn't matter. And set delete pending, and we assign it to a use state that we initialize with false. Then we put an async function here called handle delete, where we call our mutation. So first we set the pending state to true to set this to loading, and then we put a try catch block here. At the beginning of the try block, we call await delete node. As the argument in curly braces, we have to pass the node ID, which is the ID of the node that we render in this dialog. Again, we want to show a success toast if this succeeds. Node deleted. And then we want to call handle close to close this dialog. If this operation fails, again we want to show this error in the console, failed to delete node, and let's also render the error in here. And then we want to show an error toast. Failed to delete node, please try again. And in the finally block we want to reset the pending state. set delete pending false. That's our handle delete function. We want to call this function when we click our delete button. So we add an onClick handler here that calls handle delete. And I want to disable this button while delete pending is true, right? And I also want to change the text of this button again, depending on the loading state. If delete pending is true, this should say deleting ... and otherwise it should say delete node as before. Just one more little thing. At the start of the handle close function, I want to check if delete pending is true and return, so that while this is pending, we can't close the dialog. This just creates a better UX, but this is not strictly necessary. Let's save everything and try this out as well. Back in our app, we should now be able to delete nodes. Delete, and it's super fast, and again our front end is updated automatically because this is taken care of by Convex. Super cool. So the basic Node app is set up, and next we will implement our AI chatbot. For our AI chat, we will use the OpenAI ChatGPT API. Now this costs money and you have to provide payment details in order to use this. There is no way around this because all these LLM APIs cost money. It's extremely cheap. You pay like a fraction of a cent for one of these generated messages. And you don't have to use the OpenAI API. There are also other providers, and the Vercel AI SDK supports all the popular ones like Anthropic, Claude, and all of this stuff. But the most popular one is the OpenAI API. Go ahead and create an account if you don't have one yet. Inside your account, you have to go to the settings. Here you first have to set up billing, and then we have to create an API key. I've already prepared one. Of course, I'm gonna delete this one later, so don't even try to use my API key, you little weasel. But yeah, we have to copy this API key, and we don't put it into our project. Instead, we put it into our Convex app. Remember, earlier I said that Convex is our backend, so all the API keys that we need to use on the backend have to go into our Convex project, not into our Next.js app. So here in the Convex dashboard, we go to Settings, Environment Variables, and we add a new one. And this has to have this exact name, OpenAI _API _key. With this name, the Vercel AI SDK will automatically recognize it. Of course, if you use a different API, then you have to use a different variable name. They are listed in the Vercel AI SDK documentation. Okay, and in here I want to paste the OpenAI API key and save this. Next, we have to create a server endpoint where we can make a request to the OpenAI API. And this goes into this http.ts file where we already set up the authentication routes earlier. These endpoints are not regular Convex queries. Remember, for our nodes, we created this query to fetch the nodes, but these queries can only be used via the Convex front-end APIs like useQuery or useMutation. Our API request is a bit different. It has to be called later by the Vercel AI SDK. So we need a public server endpoint, and we create them in Convex in this http.ts file. This feature is called HTTP actions, and it's described in the Convex documentation. So we have queries, mutations, we have normal actions, which we will also take a look at later, and we have HTTP actions. When you need each of them is described in the docs. But of course, if this is confusing to you, just follow along. I will walk you through it step by step. So what we do is, after add HTTP routes, but above export default, we take the HTTP object and we add a route to it with .route, parentheses, curly braces. Then we have to set a path for this route, which is the URL where we will reach this. We can add anything we want here. We want to put this under /API/chat. So these HTTP routes are the equivalent of API route handlers in Next.js, where we set up a route.ts file to create a backend endpoint. But since we don't use Next.js as our backend, but Convex, this is how we set up these API routes. We also have to define the method. This will be a post request. So we send data to this endpoint, and this data are our chat messages. And then, just like for queries and mutations, we pass a handler. But for this handler, we pass an HTTP action, this one. parentheses. And to this, we have to pass another error function with our usual context object. And the second argument is the request. Then we make a right arrow, curly braces. And in here, we can put the logic of the server endpoint. Just like in our query, we want to start with authentication, which works the same. We create a const user ID. We call getOfUserID that we already used before. And we pass the context object to it. And if the user ID is null, we know that the user is not authenticated, and then they should not be able to call this endpoint, right? But here we have to return a default HTTP response with response.json, parentheses, curly braces. In here we put error message, which will say unauthorized, and we set the status code to 401. So this is a regular HTTP endpoint. But one of these curly braces belongs over here. There we go. Later, when we call this endpoint, we send the chat messages to it. So we have to read them from the request body. So what we do is, we destructure a const, and in here we find messages. We also set the type of this manually like this. So we get type safety and auto completion. And the AI SDK provides this UI message type, but I have to import this manually, it seems. So we import from AI. This is how this package is called. And in here we should have the UI message type, this one. And we pass an array of these UI messages to this endpoint. And how do we get it? We get it from await request.json, parentheses. So those are the messages inside our AI chat window here. We send them to the backend, and then we can send them to the OpenAI API to generate the next response. Now, the more stuff you put into this request, the more expensive the request becomes. Again, it's very cheap, like you usually just pay a fraction of a cent, but nevertheless, it makes sense to not send too much data there. So what we can do is, we create a const last messages, and we only take the last 10 messages out of this array, because this should be enough, right? If we have 20 messages in the chat, we don't need to send the oldest ones. We get them via messages.slice, to which we pass -10. So those are the 10 latest messages in this array. This makes the request cheaper, and it avoids that we exceed the context window. Then we create a const result, and this is where the magic happens. The AI SDK has this streamText function, which is an import from the AI package that we already imported earlier, this one. And in here we do all the configuration, parentheses, curly braces. We define the model that we want to use. For this we import OpenAI from this package here, import OpenAI from @AI-SDK/OpenAI. We call this as a function. And to this we pass the model that we want to use. Now, if you really want to save money and you want to pay the smallest price possible, then use 3.5 Turbo. It's an older model, it's not as good, but it's the cheapest one. If you want higher answer quality, then 4.0 is a good one. It's also not super expensive, or you can also use 4.0 Mini, which is a bit cheaper. Doesn't really matter, just use one of them. For now, we will keep this chatbot simple. It will not have access to the user's notes yet. Instead, it will just give simple answers to simple questions so that we see how this works. After the model, we can pass the system prompt. This is how we give instructions to this LLM. And here we can just write in plain English. You are a helpful assistant that answers the user's questions. Later we will make this prompt more sophisticated with better instructions, but for now this is enough. Then we pass the messages, which are our last messages, but we first have to call convert to model messages. Because remember, last messages are of this type UI message. UI message are the messages that we show on the front end in our chat here. On the back end we have a slightly different type called model message. And this function, which is coming from the AI SDK, maps between these UI and model messages. And then we can also pass an error handler so that we get some feedback if something goes wrong. And here I just wanna print the error to the console as usual. And maybe we also put a string in front of it saying streamText error colon, so that we know that an error happened in here. Then below const result, so below this closing parenthesis, we return result.toUI message stream response, this one here. This takes this model message, it turns it back into UI messages, and it streams the text so that we don't have to wait for the full response to be generated. Instead, we see a stream of the text, which looks like this. Give me my grocery list. It creates this really cool effect where the text streams in, like this. And it's also faster than waiting for the whole response to be generated. This is what this function takes care of. It's provided by the AI SDK, and we have to call this. Now, since this HTTP action runs on Convex, our front end will be on a different URL, which means that we have to configure CORS, otherwise this will be blocked by the browser. Which we do the following way. We add another HTTP route below this one, so down here above the export default, which looks like this, and I'm too lazy to type this in by hand. I will put a link to this file into the video description, copy this block from there. This configures CORS, which is necessary to allow a post request to this endpoint. So copy this part in, and then one more change. We go into this UI message response function again, add curly braces, and here we have to define a header like this, headers colon, new headers, parentheses, curly braces, and in here we put this. So this first string, make sure to spell this correctly, again is necessary for CORS. That's the origin that we allow. We allow requests from all pages, and to be honest, don't know what this is for. I just found this online while researching how to set up CORS. I just know that this seems to be necessary as well. If there is any confusion, again, the link to this file is in the video description. Copy it from there and just copy the CORS setup. Save everything, and then we go to the AI chat button component, because this is where we make the request to this endpoint. First, we need the URL where we make this request to. The URL is /API/chat, but we still need the base URL, right? We can find this one in our .env file, the convex URL, this one here. But these HTTP actions have a different suffix. Instead of .cloud, this should say .site, but we don't want to change it here. We need this one. We just copy the name of the environment variable, next public convex URL, back into the AI chat button, and then above the AI chat button function, we create a const. Let's call it convex site URL. We take this environment variable via process.env.nextPublicConvexURL, and we call replace on it like this, parentheses. And again, we want to replace this .cloud at the end for .site, which we can do with a regex, which looks like this. So this finds the .cloud at the end of the string, and it replaces it for .site. And then we have the correct URL where we can call this endpoint add. Okay, so currently the AI chat does nothing. We can type in text in here, but we can't even send it. This is what we want to implement now. So we go down to the AI chat box here, and we add a new state to the top inside the function, called input and set input. And this is a use state that we initialize with an empty string. When we make a request from this front end to our HTTP action, we have to send the authentication token manually. We didn't have to do this for our normal mutations and queries, because these can only be called by Convex and the authentication is handled automatically. But for these actions, we have to do it manually. So somewhere below, we create a const token, which we get from useAuth token, which is another import from Convex. We call this, and this is our authentication token that we can send to the backend. Then again below, we destructure a const and call useChat. Looks like we have to import this manually again. This is an import from the AI SDK's React package. And this is what calls our endpoint here, our chat endpoint. So back down. Now we can call useChat. parentheses, curly braces, and here we have to do a little bit of configuration. We have to define the transport, for which we pass a new default chat transport, which again is coming from the AI package, parentheses, curly braces. Here we define the API, that's the endpoint where we have our chat. Remember, that's /API/chat on Convex's site URL. So let's put in backtick string here. In here we want to render the Convex site URL that we created above, /API/chat. That's the endpoint where we want to make this request to, comma. And in the headers, we have to send this authentication token, colon, curly braces. This header is called authorization. You have to use this exact name. And the value is bearer because this is the bearer token. And here we want to put the token value. So we send this authorization token in the header to this backend so that we can properly authenticate here. Because remember, here we check for the currently authenticated user, and this is coming from this token. This is important because if we allow anyone to call this endpoint, then we have no protection. And remember, these LLMs cost money. You don't want to allow everyone to make a request. Only authenticated users should be able to call it. Okay, and from this useChat function, we get back a bunch of different values. For example, the chat messages or the send message function. There are more values in here that we will use later, but for now I want to keep this simple. So we want to call this send message function with our input when we submit our form, right? So somewhere down here, we need an onSubmit function. OnSubmit that we call when we send our chat form here, when we submit this. This is just a normal HTML form. In here we get past this event, which is of type react.formEvent. This is just basic React stuff. In here we have to call e.preventDefault because by default forms refresh the page. We don't want this. And then below we check if input.trim. This way we avoid that someone sends an empty message with just white spaces. Trim removes these white spaces from the beginning and the end of the string. And if it's empty, then we don't want to send it, right? We only want to send it if it contains content. Then we can call this send message function from the useChat hook. In here we pass the text, which is the input. And the input is our state that we created up here. Pretty simple, huh? And after we successfully submitted this message, we want to reset the input state to an empty string. I think this is pretty straightforward. Okay, and we want to call this onSubmit function when we submit our form. So we scroll down, somewhere here is our form, to which we can pass the onSubmit function, which is our onSubmit function, with an uppercase S, this one. So now we can already send messages to our backend, but we don't yet render them in the UI. They are contained in this messages array, and we want to render them somewhere here where I left this to-do comment. Render the messages here. So let's remove this to-do and instead render messages.map, where we get past each message and we can render a UI element as usual. We will create a nice looking message component for this, but for now maybe let's just render a paragraph tag. And in here let's just stringify the whole message for now with json.stringify so that we see what's in there. Later we will create a nice message component, and we also have to give this a key for which we can use the ID of the message. One more thing, we also have to update our input state here, right? With the input of our chat text area. So somewhere down here is this text area. We want to set the value of this to our input state. And when the input changes in the onChange callback, we get this event object, and we can use this to update our input state like this. e.target.value. Again, this is basic React stuff. After we made these changes and saved them, we should be able to chat with our AI. Let's refresh the page just to be sure and then give this a try. So when I send this message, it uses the useChat function to send this to our chat endpoint, which then sends this to the OpenAI API with this prompt. It gets a response back, and this response should be streamed to our front end, where it ends up in this messages array, which we render in the UI. So let's try this out. Hi. There's the first message and this is the response. So the AI answered, hello, how can I assist you today? We see all of this data because we just rendered the whole JSON, but that's fine for now. How can you help me? And it streams in the response, as you can see. It's not formatted yet, and the chat also doesn't scroll down automatically yet. We will take care of all of this. But let's go back into our code and create a component for these chat messages. We could put it into a separate file, but we can also put it directly in here. I like to have these components in one file if they belong together and are not too big. But that's personal preference. So we create another function called chat message. And this chat message will take props, chat message props. It will take the whole message, which is of type UI message again. Remember, we used this on the back end already. And on the front end, we render these UI messages. So here we take the chat message props, and in here is this message. Now, when we take a look into this JSON again, we can see that a message has this parts array. This is an array, and this can contain multiple steps. So we have step start, and then we have another step of type text. And this is the actual message that we want to render on the screen. So we have multiple steps in each message because a message can consist of different things like a tool call that you will see later, a message or a second message. And what we basically want to do is we want to render the latest step, the last one in this array. So again, here we have a step start and a step text. And we want to render the text, which is the last step. So at the start of the chat message function, we create a const called current step. We take message.parts, which is this array, and we want to get the last element, which we can get from message.parts.length -1, because this is the last index. And then I'm going to paste in the UI for this message. Again, I'm too lazy to type this out by hand. It's a waste of time. It's just UI. You can either pause the video and type it out by hand. It's this block here. Or again, I will put a link to this file into the video description. You can copy it from there. But I recommend that you type it out by hand so you understand the code properly. And we have to import this markdown component from the components folder, because we will later tell the AI in our prompt that it can return markdown. And we use this component that I prepared to render this markdown via React Markdown, so that we can render lists and links and all of this stuff, which just makes the response look nicer than just plain text. Other than that, this is just styling. It checks the role of the message, which can either be a user or the AI assistant. And depending who sends the message, we align this either on the left or on the right and with slightly different styling. This is what we are doing here. And then we want to take this chat message and render it up here instead of this paragraph tag. So here we render a chat message object. Again, we set the key to the ID of the message. Then we have to pass the message itself and close this. And then we will have a nicely formatted chat message. But Prettier is complaining. It looks like some curly brace down here is messed up. Yeah, I just deleted it. I pasted one too many. Okay, let's save everything. Try this out again. And there we can already see the result. Now we have these nice looking formatted chat messages with markdown formatting. Super cool. Let's try this again. Let's try it to send us a link. Can you give me the link to Google search? ? And it will stream in the response. Yeah, it didn't format it in Markdown. Whatever. Maybe let's try this again. Give me a list of movies to watch. And by the way, this doesn't automatically scroll down, but it will do it later. So this looks much better. We have bold formatting. We have numbered lists, we have unordered lists. Really cool. Yeah, next let's improve this chat a bit so that it automatically scrolls to the bottom. And we also have to implement some other features like sending this input field when we press enter, or this delete button here. Let's add all of this. And also, while the chat is still empty, I want to have an initial welcome message here, because it shouldn't just be empty, right? This looks a bit weird. It should have a welcome message from the AI. Okay, what we do is we scroll up to the AI chat box component, which is here. And above it, we create a const called initial messages, which again is of type UI message, and it's an array of AI messages. So we create an array like this. In here we put an object, and here we should get autocomplete because we set the type to UI message. So those are the fields that are inside the UI message. We have to set an ID. We can set this to anything we want. Welcome message makes sense. We set the role of this to assistant because this message should be by the AI chatbot, right? And then we have to set parts like this. This looks a bit complicated, but this is how these UI messages are structured. They consist of separate parts. Again, this is an array in which we put one object. We set the type of this part to text, because this is a text message. And then we can send the text itself via a string. And that's the welcome message. I'm your notes assistant. I can find and summarize any information that you saved. Of course, you can set this to whatever you want. And then we pass this initial messages to the useChat function here. After the transport argument down here, we can also pass messages, which are the initial messages, like this. And now whenever the chat is empty, we should see the initial message. Perfect. And since these initial messages are part of this messages object here, they will be sent to the backend. So when I send hi, for example, the backend endpoint will receive this first message and the hi message. And if we have more messages in here, then we will send them to the backend as well. And remember, we always take the last 10 messages to send them to the ChatGPT API. And then, as I mentioned earlier, the useChat hook returns more values than these two. We also want to get set messages and the status. The status will tell us if the response is currently loading or streaming in, and we want to use this information to one, show a loading indicator, but also disable the send button if the AI is currently generating a response so that we cannot send two messages at a time. So what we do is below const messages end ref, we create another const called is processing. And we set this to status is equal to submitted. Then the AI generates its response and our input button should be disabled. Or if the status is equal to streaming, which means that the response from the AI is currently streaming in. If it's either of these two statuses, we want to set is processing to true. Then in the onSubmit function, here after if input.trim, I also want to check that is processing is false. So to ampersand signs, exclamation mark is processing. Only if is processing is false, we should be able to send the next message, because that means the AI has finished sending its message. Then we go down to the button that has the trash icon in it. That's our delete button here. We want to use this one to clear the chat. So when we click this button, we simply call set messages and we set this to an empty array. No, actually, we want to set this to initial messages so that we show this welcome message again. So let's save this and try this out. I send hi. And while the response is being generated, I should not be able to send another message. And when I click this delete button, it should clear all the messages except for the first one. There we go. I also want to disable this clear chat button while is processing is true. So let's do this as well. Disabled equals is processing. I also want to disable the send button down here while is processing is true. That's the submit button down here, this one. So we pass the disabled prop here as well. And this should be disabled either if input.trim is not empty, so that we can only send it if we type something in, or if is processing is true. So now when the input field is empty, it's disabled. And while we get a message back from the AI, it's also disabled. Okay, cool. Then we also want to scroll down automatically when we get a new message. For this, we will use a use effect. let's put it up here below the isProcessing const. Where exactly you put it doesn't matter, of course. We create a useEffect to which we pass an arrow function. We want to scroll down whenever we receive a new chat message, but only if the chat box is open. So first we check if open is true. Then we take this message as endRef, which is this ref that I already prepared. And this is attached to this div. And this div is always rendered below the last message. So always at the bottom of our list we have this ref, and this is the position where we want to scroll to. So messages endRef.current.scroll into viewer, parentheses curly braces, and we set the behavior to smooth to get a smooth scroll. And then let's not forget to add the dependency array to useEffect, otherwise it will be executed on every render, which is not what we want. We only want to run this if open changes or if our messages array changes, which means that we got a new message. Let's save this and try this out. Give me a long list of healthy vegetables. And this should now scroll down automatically. And it works. Of course, you can fine-tune this behavior to the way you want it to work, but I think this is pretty cool. Next, I want to be able to send a message when we press enter, which isn't the default behavior in the text area. When we press enter, we get to a new line so that we can write longer messages. In order to send the message when we press enter, we need to set up a key handler ourselves. Let's put it below the onSubmit function. Const handle key down. We assign an arrow function, which gets this keyboard event passed to it. And here we check if e.key is equal to enter, so we press the enter key, and exclamation mark e.shift key. So only when we press enter but not shift, we will send the message by calling onSubmit, and to it we pass this event. So it calls our onSubmit function. When we press the shift key while we press enter, then I want to create a line break so that we can still send longer messages. You can also revert this. You can send the chat message only when you hold the shift key down, but this is up to personal preference. And I think we have to cast this to React.form event so that TypeScript doesn't complain. I think we have to do as unknown as React form event. This is TypeScript magic, but I think this should work. And then we have to pass this handler to our text area. So let's scroll down again to the text area. And somewhere in here, we can pass on key down, and we pass this handle key down object. Looks like the type here is wrong. Yeah, let's go to the handle key down handler again. I think we have to call this react.keyboard event like this. And I think then we also don't need this cast here anymore. Perfect. Now it doesn't complain anymore. Let's try this out. So when I send a message and hold the shift key down and press enter, we get to a new line. But if I just press enter, it sends the message. This is exactly what we want. Perfect. Then we also want to render the current status, right? Because right now we only disable our button, but I also want to show a loading indicator, or if something went wrong, I want to show an error message, because this request can also error, right? So what we do is below if open return null, right here. We create a const, last message is user, so that we know if the last message was sent by the user or by the AI. We find this out by taking the messages array at the last index. So again, messages.length -1, which is the last element. And if the role of this last message is equal to user, we know that the last message was sent by the user. Then we scroll down to where we render our chat messages, which is happening here. Here we also want to render a loading indicator or an error message if necessary. So below we put an expression and we check if status is equal to submitted, so the user submitted their message, and the last message is still by the user. And how did I know this combination of states? I figured this out by trial and error. This is just the combination of checks that worked to show a loading indicator at the correct time. And I already prepared this loader component at the bottom, which we want to render here in this case. And then below we check if the status is equal to error, in which case we want to render an error message. But this one I haven't prepared yet. Let's put it at the bottom. So here is the loader that I have prepared. And here we also create an error message. Again, you can put this into a separate file if you prefer, but I'm going to keep it in here. And here we return a div that will say something went wrong. Please try again. And let's style this div with text sm and text red 500. And then we want to render this error message here if the status is error. And now we should have a proper loading and error state. Let's try this out again. What can you do for me? And there we go, that's the loading indicator. And we get a message streamed in. Super cool. So now we have a basic chatbot, but it can't yet search through our nodes. This is what we will implement next. To find relevant nodes, we use a technique called vector embedding, which is really cool because it allows us to compare text by its meaning. So the way it works is you take a piece of text, this can be a single sentence or a paragraph, and you send it to the OpenAI API to a special embedding model, which turns it into an array of numbers that look like this, with a lot of decimal points. But instead of 4 numbers, we will have over 1000 of these numbers in this array. And in this number is the meaning of the text embedded, so to speak. So if I have a text that says, my favorite color is blue, then we can turn it into such an embedding. And then we take a similar sentence, for example, what is my favorite color? Which is not quite the same sentence, but it's very similar. Because again, we talk about favorite color. Then it will also have an array of numbers that is very close to the first array. If the meaning is more different, for example, I love my grandma, then it will have an array of numbers that is further away from the other two, because the meaning is much different. And then we can use special functions to compare these different vectors and how close they are together to find relevant pieces of text. If this is confusing, don't worry, you don't have to understand this in detail, just follow along. We want to store these vector embeddings in our Convex database because Convex supports this out of the box, which is really nice because if we put them into a separate database, it makes everything more complicated. It's much more convenient if we can put the embeddings into the same database as our nodes. So here we want to put another table, which we do in our Convex schema. Let's call it node embeddings. The name is up to you. And again, we call define table to create this table. In each of these embeddings, we store the content, which is the original text that we turned into an embedding, which is a string. Again, this can be a sentence or a whole paragraph or even a whole node. This is up to us. Then we store the embedding itself. This is this big array of numbers that I showed you a moment ago. So this is of type v.array. And to this we pass v.float64 and add another pair of parentheses here. Then we need the ID of the node that this embedding belongs to, so that we can find the relevant node. Node ID is of type v.id of this nodes table. And we also need to store the user ID in here, so that we can find embeddings only for a particular user. So this is the whole table. After the find table right here, after this closing parenthesis, we have to create another index, which we call by node ID, so that we can search for embeddings only for a particular node, comma, and then the value by which we want to create this index, which is the node ID. And one more step, before the comma, we call .vector index, which creates this index that is necessary for the vector search. We call this by underscore embedding, comma curly braces. We have to define the vector field, which is this one here, embedding. So we set this to embedding as a string. The dimensions, this defines how many of these numbers we put into this array. And the default for OpenAI is 1536. So put this number in here. And then we add filter fields and set this to user ID in an array. This way we can search for embeddings only for a particular user and filter them out from the rest. Okay, set this up, save the changes. Remember, these changes will only be pushed to Convex when npx convex dev is running. Make sure this is running so it adds these new tables. Then we want to create a file that makes a request to the OpenAI API to create these embeddings. Let's put this into the lib folder here. In src, lib, right click, let's call it embeddings.ts. Here at the top we define the embedding model and put it into a variable. Again, we use this OpenAI object from the AI SDK, call.embedding, and here we define the model. We can set this to 3 small, which is a bit cheaper than the large one, but it's still pretty good. Ada is the old one. We use this one. Then we have to decide how much text we want to embed at once. We could, of course, just embed the whole node. But what if we have a lot of different stuff in here? What if we have, my favorite color is blue, my favorite food is steak, on Monday I want to go eat ice cream, whatever. The point is that we have a lot of different meanings in this one text. And if we put all of this into one vector, then it will be very inexact because it talks about many different topics at once. So a better approach is to split this text into separate chunks. For example, we could have this sentence here in one embedding, this in another, and this one in another. There are different algorithms to split up such a text. A simple one is to just split it up at line breaks. So each of these separate lines, each of these paragraphs will be in a different vector. Let's implement this approach. So below the embedding model, we create a function called generateChunks, to which we pass this input as a string. And then, as I said, we want to take this input and we want to split it at 2 line breaks, \n, but we have to wrap this into a string so that we separate each paragraph. A paragraph often has a coherent piece of meaning, right? Then we also want to remove the empty ones. So we map this, we take each chunk and we call chunk.trim to remove the empty white spaces. And afterwards we call .filter and pass boolean with an uppercase B. This removes the empty strings. And then we need to make the request to the embedding API. So we export an async function. We don't export this one here because we only need it internally inside this file. This function will be called generate embeddings in plural, because for one node we will generate one or more embeddings because we split the text, right? So here we pass the input again. And we can also define the return value so that we get type safety and autocomplete in here. So it will return a promise because we make an async request. And in this promise will be an array. And each of these will contain the text itself as a string and the embedding, which, as I explained earlier, is just an array of numbers. Let's see if I can format this properly. Yeah, there's a pair of curly braces too many. This one here in front of array and this one should be removed. This is the correct type. So this will return a promise with an array that contains one or many of these embeddings together with the text itself. And this is what we generate in here and then return it. So first we want to chunk up the text. Const chunks equals generate chunks. This is the function we just created. And we pass this whole value input to it to turn a node or whatever other text we pass to this function into a bunch of different chunks. Then we create and destructure a const and we call await embed many, which is a function from the AI SDK. Parentheses curly braces. Here we define the model that we want to use, which is our embedding model, and the text chunks that we want to embed. With this function, as the name implies, we can embed multiple pieces of text at once. This is exactly what we need. And in here we get returned the final embeddings, which are these vector arrays. And then we want to return them together with the text itself, right? So we return embeddings.map. Here we get each embedding and the index. And we return parentheses curly braces. We want to return an object that contains this data. the content, which are the chunks at this index, and the embedding. So now we take a block of text, we turn it into chunks, we embed these chunks, and then return this data to the color of this function so that we can use it when we create a node, for example. Let's do exactly that. Let's save this and then go into our nodes.ts file in the Convex folder. Here we create nodes. And when we create a node, we also want to create all the vector embeddings for a node and store them in our database. The only problem is, inside these convex mutations, we can't call the OpenAI API. We can't call any third-party APIs, not even make a fetch request. We can only use the convex database, and here, this is what we have actions for. Actions are another convex feature where we can make this request to external APIs. We can just not do it inside a normal mutation. For this, we create a new file, still inside the convex folder, which we call nodesactions.ts. The name is up to you. At the top, we put use node as a string. This way we can use Node.js APIs in here, like calling the OpenAI API, which is a Node.js package. Let's put the nodes.ts file on the right side because we will cut and paste some stuff over here. So in the nodes actions file, we export a const, which again we call create node. But this time it's not a mutation, it's an action. Parentheses, curly braces. So later on our front end, instead of calling this create node mutation, we call this action instead, but the rest works basically the same. We need the same arguments and the same return value. So let's copy this. Then we also have to pass a handler, which has the same structure. It's an async function that gets passed the context and the args. And then we create an arrow function. We also want to do authentication in here. Let's copy this over as well. And let's import v and get of user ID. The difference to our old mutation is that now we also want to create these embeddings before we insert this data into the database. And again, we can only do this in an action. So below, we create a const text. And what I want to do is, I want to take the title and the body of each node, and I want to put them into a single string that we can then chunk and generate embeddings from. So in the backtick string, we put args.title, 2 line breaks, \n, and another variable, args.body. So we have something like this. Node title, then an empty line, then paragraph 1, paragraph 2, and so on. And we pass all of this to our embedding function. So we create a const embeddings and call await, generate embeddings, which should be exported from our lib folder, export async function, but import doesn't work. Let's import this manually, generate embeddings from the lib folder like this. We call it here, generate embeddings, and we simply pass this text to it, and the rest happens inside the function, the chunking and the embedding request. Now the database operation itself still happens inside this mutation, and we then call this mutation from this action. But we renamed this from create node to create node with embeddings. And we changed the mutation function to internal mutation. This way, only our convex functions can call this mutation. We can't call it from the front end, which makes sense because we only want to call this function. And this one is only be used by the action. We don't want to call create node with embeddings directly from the front end. Now, since authentication already happens over here, and we can't call this from the front end anyway, we will remove authentication from this function and instead pass the user ID as another argument to it, which again is of type v.id from the users table. This is a user ID. And we will also pass the embeddings that we create here to this function so that we can store them in our database. So another input value, embeddings colon, this is a v.array, which contains a v.object, parentheses, curly braces, And those are the embeddings. So in here, remember, we have the embedding, which is this array of numbers. So v.array, v.float64, which we also used earlier, and the content of the embedding, which is the original text. So this is the same data that we create over here, and we want to pass this to this function. Make sure to spell all of this correctly. So inside this handler, we still insert our node, right? But now the user ID is coming from the args. So we change this. And now we also want to store these embeddings in the database, in the table we created. So below, in Convex, it works like this. You create a loop in JavaScript for const embedding data of args.embeddings. So we want to loop through all the embeddings that we pass to this function and then store them in the database. So await context.db.insert. Where do we want to put this? Into the node embeddings table, comma, and the data itself. So here we have to pass the content, embedding, node ID, and the user ID. So let's do that. The content is embedding data.content. The embedding is embedding data.embedding. The node ID is coming from this operation that creates the new node. This actually returns the node ID. We can store it in a variable and then use it down here. And the user ID is coming from the args again. And we have to remove this return keyword. And below this for loop, down here, we want to return the node ID like we did before. So now in the handler, we create not only the node itself, but also the embeddings. And we connect each embedding to the corresponding node and user so that we can search them later. Now the way that Convex works is that everything we put inside this handler, every database operation, will be executed in a single transaction. And this is important because what if we create the node successfully, but one of these operations here fails and it aborts all of this? Then we have a node without the embeddings. This would be pretty bad because then we couldn't use vector search for this node. But since Convex automatically executes all of this in a single transaction, if one of these operations fail, then the node will not be created either. It's either all or nothing. This is what a transaction is for, and it happens automatically in Convex mutations. So now over here in this action, we want to call this internal mutation. Remember, this returns the node ID. And we call await context.run mutation. This is how we execute a mutation from another Convex function. Parentheses. Here we pass internal. Looks like we have to import this manually again. This should be in this generated folder. Internal.nodes. And then we have this create node with embeddings function, comma, curly braces, and in here we put the values that we want to send over. So the title is in args.title, the body is in args.body, the user ID is from our authentication function, and the embeddings are returned from our embeddings function. And afterwards, we want to return the node ID to the front end. And we also have to set the type of this node ID explicitly, otherwise TypeScript complains. So this is an idea from the nodes table. Type it out like this. And now TypeScript doesn't complain anymore. So to recap, we changed create node from a regular mutation to an action because then we can call Node.js APIs like our embedding function. But to put the node and the embeddings into the database, we still call this mutation. But this is now an internal mutation, which means that we can only call it from other Convex functions. And this takes care of inserting the node and the embeddings into the database in a single transaction. So now everything is safe and should work properly. Now let's also take care of the delete node function, because when we delete a node, we also want to delete all the vector embeddings, right? And we can leave this a regular mutation. This doesn't have to be an action because here we don't call the OpenAI API. We only delete something from our own database. So here at the bottom, after we deleted the node itself, we need to fetch all the embeddings and put them into a const. All the embeddings for this node, of course, which we get from the database .query node embeddings with index. Here we use this by node ID index. And again, we use this error function with this queue object where we compare that the node ID of the embedding is the same as the node ID that we pass in the args. This way we get the embeddings only for this particular node, and not to forget we call this collect function again. And then again we have to use a loop to delete all of them. So for const embedding of embeddings, we call await context.db.delete. There is no delete many function. We have to delete all of them in a loop, but they will still be executed in a single operation by Convex and also in a transaction again. So when some of these operations fail, the whole function will be rolled back. We either delete everything at once or nothing. We don't have partial deletes. And here we pass the embedding ID. This is the one we want to delete, right? Actually, I want to move this line here where we delete the node itself to the bottom. I don't remember if the order matters. I think it shouldn't, but this is how I prepared it in my code. But I think it doesn't matter if we first delete the node or the embeddings, because again, this is all executed in a transaction. Just one more little change on the front end. Of course, in our create node button, we have to change the call up here because we still call the old mutation. So first of all, instead of use mutation, we have to call use action now because this is an action. And the create node function is now inside the node's actions file, but the rest is the same. Let's save everything and try this out. If you have existing nodes, delete them first because they don't have any embeddings yet. Then I create a node, title 1, paragraph 1, paragraph 2 to make sure that splitting works correctly. Still paragraph 2 because here is no empty line, so this should still be one paragraph, and paragraph 3. Now when we save this, we should create the vector embeddings and our node. Okay, there's our node. And let's see the vector embeddings in our table. Here in the Convex dashboard, we click on data. Here we now have this node embeddings table. And voila, here are our embeddings. And we split up the text into different chunks. The title is one chunk and each paragraph. And this is the embedding value, which is this huge array of numbers. Every vector is also connected to a particular node and a user. And now we can do this to do this similarity search and find only relevant nodes. Remember how I explained earlier that these vectors contain the meaning of the text. So now we store each paragraph together with its vector. And when we want to find a relevant node, what we have to do is take our chat message, for example, what is my favorite color? And then also turn this into a vector embedding so that we get a meaning and we can use this value to compare it with all our vectors and find the closest ones. Because then we know that this node and this paragraph are related to our query. For this, let's go into our project and into our embeddings file in the lib folder once again. We have this generate embeddings function, and I want to put another function in here, export async function called generate embedding in singular, so that instead of an array of embeddings, we only return a single embedding, but the rest is the same. Again, we pass the text in here, which will later be our query. And this will return, again, a promise, but not an array. This time it's just the vector itself, the array of numbers. Again, we create a const that we destructure. We call await, and instead of embed many, this time we call this singular embed function from the AI SDK. Again, we set the model to the embedding model, and we pass the value. And from this function, we get a single embedding this time, which we want to return here. And then we can use this to embed our chat queries. We call this function and do the vector comparison in our nodes actions file. Here we have create node, And at the bottom, we export another const called find relevant nodes. This will be an action again, but an internal action. Remember, internal means we can only call it from other convex functions, not from the front end. Parentheses, curly braces. We will later call this function from our HTTP endpoint. But this HTTPS file can also not call Node.js APIs. This is why we have to put it into this action file. This is also what we earlier did for the create function, where we called the OpenAI embedding API. So everything that calls a Node.js API has to go into this file as a general rule. And as usual, in here we define the args. To this function we will pass the query, which is the text query that we want to create an embedding from, and then find the relevant nodes. And then again we define a handler, which is an async function that gets passed the context and the args. And actually we also need the user ID in here, so let's add this as well. User ID colon v.id from the users table, right? Again, since this is an internal action and can't be called directly, we can pass the user ID instead of doing authentication inside the handler. So now we create a const embedding and we call our singular generate embedding function, to which we pass args.query. Then we want to do the vector search. For this, Convex provides a special function, because all of this works out of the box in Convex. We create a const results, then we can do a context.vector search. Over which table? Over the nodes embeddings, because this is the table where we store our vectors. Comma, then we have to define the index, which is by embedding, comma, and then pass some arguments. The vector is the embedding we created from the query. So we take the user query, turn it into a single embedding, and pass it here for the similarity search to find the relevant embeddings in our table. We can also limit this to a number. For example, we only want to return at most 16 embeddings. This should be enough, but you can also pass a larger number. And then important, we only want to return the embeddings for this particular user. So again, we use this filter function. We call q.equals. The user ID has to equal the user ID that we find inside the args. And these results are automatically sorted by relevance. So the vector that is closest to our query will be at the very top, and the second one will be at the second place, and so on. So this is sorted automatically. Let's also print them to the console to see what we actually get back here. Vector search results colon, and then we log all the results in the console. When we hover over results, we can see the data that's in there. The ID of the embedding and the score. The score is the similarity. So the higher the score, the closer these embeddings are in their meaning. And we fetch up to 16 of these vectors. Now I also want to filter them so that we only get the vectors that are above a certain score threshold. Because if the score is too low, then these two embeddings are not really related to each other. And there's no point in sending them to the LLM if the score is too low. So below we create a const. Let's call it results above threshold. And we do a simple JavaScript filters, nothing special. Results.filter. We take each result and we check that result.score is greater than 0.3. And I figured this out just by trying different values. Above 0.3 means that the meaning is relatively close together and it makes sense to keep this embedding. And everything that's below 0.3 will be removed from this array. Then we only need the IDs of these embeddings. So below, again, we create a const embedding IDs. We take the results above threshold and we map them to only the result.id, because we need these IDs to fetch the embeddings from the database, because the results doesn't contain the embeddings themselves, only the IDs. So we need to fetch them ourselves. In order to fetch the actual embeddings, we have to set up another query, which we do in the convex nodes file. So let's put this on the right side. Here we have get user nodes, create node with embeddings, and we need another function. Let's put it at the bottom. Export const fetch nodes by embedding IDs. So instead of returning the embeddings themselves, we return the nodes that belong to these embeddings. Again, this is an internal query because we only want to call this from other convex functions. It takes arguments. What does it take? It takes these embedding IDs, right? We pass them to this function, and the type of this is v.array of IDs of node embeddings. That's the name of the table. Then below args, we implement the handler, which as usual is an async function, context args. So now we have the embedding IDs. We need to fetch all the embeddings that belong to these IDs, which again we do with JavaScript loops. So we start by creating an empty array. We loop through all the IDs of args.embeddings, like this. And we want to fetch each embedding. Const embedding equals await context.db.get, where we pass the ID of this embedding. And if this embedding is not equal to null, then we want to push it into our array. Embeddings.push embedding. Makes sense, right? But this should be args.embedding IDs. Then below this for loop, we return the nodes for these embeddings, because what we want to send to our chatbot are not the single embeddings. I want to send the whole nodes to the chatbot, but only the relevant ones. So below we create a const node IDs. We create an array. In here we put ... new z. And to the z we pass embeddings.map. I will explain this in a moment. We take each embedding and we want to get the node ID out of this embedding. Actually, let's rename this to unique node IDs. I think this is more self-explaining. We create a set so that we only have unique node IDs in here, because multiple embeddings could belong to the same node ID, right? But we don't want to fetch the same node twice. So we take all of these node IDs, we put them into a set, which removes duplicate values, and then we only have the unique node IDs in this array. And then we want to fetch these nodes. So again, we create a const results, which we assign to an empty array. Again, we loop for const ID of node IDs this time, unique node IDs, of course. And then we want to fetch each node, await context.db.get ID, and put them into our array. If node is not equal to null, results.push node, and then we want to return them. And then back in the nodes actions file and find relevant nodes, we want to call this new function, which will then return the relevant nodes for this vector search. So we create a const nodes equals await context.runQuery. Remember, this is how you run queries or mutations from other convex actions. Internal.nodes, let me close this one, .fetch nodes by embedding IDs, comma, and the arguments are the embedding IDs. And then lastly, we want to return these nodes. So what we just set up finds the relevant node embeddings via a vector search, then fetches the nodes for these embeddings, and then we return them. And this way we only get the relevant nodes for the query that we pass to this function. But TypeScript complains again, and we can fix this by setting the return value of this function directly of this handler function here. So we go behind the closing parenthesis after args right here, and we have to set the type. This returns a promise, angle brackets. In this promise is an array, angle brackets, of type doc. Very important, imports the doc from the generated folder, not the convex one, the generated one. Because in here we can put our nodes table string. So this returns an array of node objects. Save these changes. And where do we call this function? We call it in our HTTP endpoint as part of our OpenAI query here. First of all, I want to update the system prompt, make it a bit more elaborate. And I've already prepared the new prompt. I don't want to type this out by hand. You can either pause the video and type this out, or again, I will put a link to this into the video description. So the new prompt is, you are a helpful assistant that can search through the user's nodes. Use the information from the nodes to answer questions and provide insights. If the requested information is not available, answer with sorry, blah, blah, blah. You can use Markdown formatting. This way we make sure that the AI uses Markdown in their responses. Provide links to relevant nodes using this relative URL structure, /nodes/node idea. Remember, this is how we open a node in our app. We set this up earlier by putting the node ID into the URL. And here I tell the AI that it can use this link format to link us to relevant nodes, which then opens the model in our app. Keep your responses concise and to the point. Again, you can copy this prompt from the video description or write your own prompt. You don't have to use the exact same one as I did. You can experiment with this. But now, how do we give this AI access to our find relevant nodes function? And this is where tools come into play. To the streamText function, we can pass this tools object. This is how we allow the AI to call functions, for example, to retrieve data from the database. We give this tool a name. This is up to us. I'm gonna call it find relevant nodes again. And then we pass this tool object here, parentheses, curly braces, where we can configure the tool. So each tool needs a description. This helps the AI figure out when to use this tool, so be explicit in here. Retrieve relevant nodes from the database based on the user's query. And the AI will take this description here into account to decide if it should call this function. Comma, parameters. Here we define the data that we need to call our function. Remember, our function expects a query. And the AI can generate this query for us via such a parameter. And here we use Zod for validation. We import Z from Zod. Zod is just a validation library, and they decided to use this in the AI SDK because it's the most popular validation library. This is very similar to this V object here, which is also there for validation, but this is used for Convex and Zod is used for pretty much everything these days. And here we say we need a query. The query will be of type string, so z.string. And again, we can append .describe to describe what this is for. The user's query. This is just a description again. And then after parameters, we pass an execute function, which does the actual function call. To this we pass an async error function, and in here we receive the query, the parameter we defined up here. And we can use this to do our similarity search. So basically just call this function, find relevant nodes, and pass the query to it. If this is confusing, don't worry, we will log everything to the console and look at what exactly is generated at each step. So just follow along. So first I want to log the query to the console. So let's say find relevant nodes query, colon. And I want to see what this here actually contains, because this is generated by the AI. Afterwards, we want to find the relevant nodes via this function. So we create a const nodes equals await context.run action, parentheses. We use this internal object again. Here we find nodes actions.find relevant nodes, which takes two arguments, right? The query and the user ID, which is coming from authentication. Actually, let's rename this maybe to relevant nodes to be a bit more explicit. And then at the end, we simply have to return these relevant nodes, but they contain some information that we don't need. There's no point in returning the user ID. We only need these other values. Basically, we want to return all the information that is useful for our LLM. The ID is important so that we can link to the node. The creation time is also useful, but of course, we also need the body and the title, but not the user ID. So what we do is here, we call .map, and we only return the data that we actually care about in an object. The ID is node._ID. The title is node.title. The body and the creation time. And whatever we return here will then be available to our LLM and automatically be used. Okay, just one tiny change on our AI chat button. We go to the useChat function call down here, and after messages we set max steps to 3. Because the tool call is a step and generating the text is another step, and by default it only allows a single step so that we wouldn't get a response back. By setting this to a higher number, we could also set this to a 2, I guess. We allow it to make the tool call and then create a text response to actually reply to the user. Save this and then we can give this a try in our app. Let me create a bunch of nodes that actually contain useful information. I'm gonna delete this one and create a bunch of new ones. So I created a bunch of different nodes, and now I should be able to ask it a question. For example, what's my Wi-Fi password, which is contained inside this node? What's my Wi-Fi password ? Now it should make a tool call. The text is empty. We will fix this in a moment, but it found the password and it provides a link to the node. Now let's take a look into our console. Into the Convex console to be more exact. This is really interesting. Here we can find the generated query. As you can see, it generated Wi-Fi password. But I didn't type in Wi-Fi password, I typed in what's my Wi-Fi password. But the AI takes this text and it generates a relevant query for this tool call. And then below are all the vector embeddings that it found together with their score. Remember, we only keep the ones that have a score above 0.3 and we remove the other ones. It found 2 embeddings, which are both coming most likely from this node. It definitely returned this paragraph here, because this is where the information is in, and then probably the title is the second vector. Let's try another question. Give me my list of movies to watch. So again, in the log we should now see a generated query, which is just movies to watch, and the embeddings it returned. Let's also try a follow-up question. And now my grocery list, please. Now again it generates a new query, which should say something like this, grocery list. It does a vector search and it finds the relevant information. And this is really cool because the AI automatically generates these queries. In the past we had to do this ourselves, but now this is handled by these tool calls here. And this will work no matter how many nodes we have stored in our database, even if we have thousands or millions of nodes. We can even create a new node and the data will be immediately available to our chatbot. Let's try this out. My favorite color, it's blue, for example. Save this. What's my favorite color? I don't even have to refresh the page. We can ask this immediately. And there we go, blue. So cool. And when I write something that does not require the AI to search through my notes, like thank you, then it will not execute this tool. It will just generate the response right away. Just one more thing. While it made the tool call, the text here was empty, right? Let's change this. We do this down in our chat message component in the AI chat button over here. Let's go into this component. And remember, we render the current step. This is the last step. But here we only render it if the step is text. The step can also be a tool call, in which case right now we render nothing. This is why the text was empty while the tool was executing. Let's change this. Below we put another expression. If current step.type is equal to a tool invocation, Then we want to render something else, for example, a div that we style with italic text formatting and this animate pulse animation. And this will say searching nodes ... and we also have to close this div. If you had multiple different tools available, then you could also distinguish by the tool name, which is another value in the step, but we only have this one tool. So if the last step is text, we render the text. If the last step is the tool call, we render the tool call. Let's see how this looks. Let's clear this. Give me my grocery list. And now when I send this, we see this text here, searching nodes, and then it streams the answer in. Yep, that's pretty much it. Now we have a fully functional chatbot that can search through the user's nodes and answer questions based on this information. But don't close the video just yet. We also want to deploy this to production because this requires a few steps and you don't want to skip this part. To get our app ready for production, we go into the Convex dashboard again. And the cool thing is that Convex automatically gives you a dev environment and a production environment with different databases. So you can make changes in development, insert data and so on, and you have a separate database in production. So what we do is in our project, we go into the settings, go to URL and deploy key and click on create a production deployment. Then wait until this is finished. There we go, and now we have this production deployment. Then we go into the settings again and click on generate production deploy key down here. We give this a name, for example, AI SDK node app. Name doesn't really matter. Save. And then we need to copy this value here. Important, in the environment variables, we have to put the OpenAI API key again because we only set it in development, right? We need it in here as well. So again, OpenAI _ API key, and you can copy the value from your development deployment, paste it in here, save this, and then we want to deploy our project. And the easiest way to deploy a Next.js project is to Vercel. For this, you have to push your code to a GitHub repository. You can do this in VS Code here under source control, create a GitHub repository. Then we go to our Vercel dashboard. If you don't have an account yet, create one under vercel.com. And here we want to create a new project. This is connected to your GitHub account. If it isn't, you can go to your account settings and make this connection to GitHub manually. And then we can very easily just import this whole repository. Import. It automatically recognizes that this is a Next.js app, so we keep this. But here we have to make a few changes. Under build and output settings, we have to override the build command, this one here, and change it to this. npx convex deploy --cmd, and then in single quotes, npm run build. Type this out exactly as I have it here. This is necessary to push the necessary code changes to our Convex production deployment. And then we have to set two environment variables. The first one is the convex _deploy key. This is the one we created a moment ago in our Convex dashboard, this production deployment key. And the next one is the convex URL. We should find this in our Convex dashboard. Let's see. Somewhere here, yeah, it's this one, the deployment URL. We need this one in our Vercel project as another environment variable. Then we click on deploy and pray that this works. And while this is deploying, we go into our project again, open the command line, and we execute this command, npx at convex-dev/auth -- production. This enables us to use authentication in production. So run this. This will again configure some stuff. Enter the URL where the site is hosted. For this we actually have to wait until our deployment is finished, because only then we will have our production URL, which is provided for us by Vercel. So let's wait until this has finished. Looks like this succeeded. Now we have our website here under this URL, and we take this URL and we paste it here in the command line in this auth command, because this is the base URL of our production deployment. I think we have to remove the trailing slash at the end, just to be sure. Confirm this with enter. Then it configures some new keys in the Convex backend. This should happen automatically. And it does some other steps, and now our app should work with authentication in production. So let's give this a try. This is a separate database, so we have to create a new user account. Sign up. This worked. We are inside our app. We don't have any nodes yet. My favorite color is pink. Let's save this node. Let's try another one. Passwords. And let's see if we can ask the AI about our nodes. What's my fave color? It searches through the nodes. Your favorite color is pink, and here's the node. Thank you. If this tutorial was helpful, please leave a like on this video and subscribe to the channel. You can find more information about the Vercel AI SDK in the documentation, and if you want me to make a more advanced chatbot tutorial, because there's a lot of functionality that we didn't use here, in fact we only scratched the surface, then write a comment below and let me know that you want to see another one. Then I wish you a nice rest of the day, happy coding, take care.